In this example, we're going to find the characteristic equation, eigenvalues, eigenvectors, determinant, and trace corresponding to a given matrix. Well, let's first figure out the determinant and trace, since those are pretty easy in this case. So it's 2 minus 12, or negative 10 for the determinant. For the trace, we have the trace of A is 1 plus 2 is 3. Okay, so those two are taken care of. Let's find the characteristic equation and the eigenvalues and eigenvectors. So we're looking for the determinant of A minus lambda I. So that's the determinant of 1 minus lambda, 4, 3, 2 minus lambda. All right. Well, when we figure out the determinant, we get 1 minus lambda times 2 minus lambda minus 4 times 3 is 12. So expanding this, we get lambda squared minus 3 lambda plus 2 minus 12. So that's lambda squared minus 3 lambda minus 10. And we want to set that equal to 0 and find lambda. So if we do that, we factor this, two numbers that multiply to 10 and add to negative 3 are going to be lambda minus 5 and lambda plus 2, which means lambda is equal to 5 or negative 2. Those are the eigenvectors. This is the characteristic polynomial here, the characteristic equation. So now we need to find the eigenvectors. So for lambda equals 5, we get, we're looking for A minus lambda I, and we get 1 minus 5 is negative 4, 4, 3, and then 2 minus 5 is negative 3. So this times xy equals the 0 vector. So if this is true, just taking a look at this, you need negative 4x plus 4y to equal 0 and 3x minus 3y equals 0. In each case, it's x equals y. And so any vector for which x is equal to y is going to be an eigenvector. In particular, we can take 1, 1. But any vector where x is equal to y is fine. So the eigenvector associated with the eigenvalue negative 2, again, we look for A minus lambda I, where lambda is equal to negative 2. So we get 1 minus negative 2 is going to be 3. And then we've got our 4. And then we've got our 3. And then we've got our 2 minus negative 2. So that's positive 4 as well. Times our xy equals 0. So this is 3x plus 4y equals 0, or 3x is equal to negative 4y. So if I take y is equal to, let's say, 3, I get 3 times negative 4 is negative 12. And on the left, I get 3 times something is negative 12, so this has to be negative 4. So anything in that direction, it could be negative 4 and 3, it could be 4 and negative 3. Really anything in that direction will be fine. So to recap, our characteristic equation, this guy here, is given by lambda squared minus 3 lambda minus 10 equals 0. Our eigenvalues are lambda equals 5 and lambda equals negative 2. Our eigenspace is given by the set of vectors 1, 1 and negative 4, 3. And really, it's the span of these. I should give myself a little bit more space there, but it's the span of these vectors. Okay. Or maybe not the span. I should be a little careful here. It's a set of multiples of these vectors. So it's these vectors and multiples thereof. Okay, so the eigenspace is consists of vectors 1, 1, negative 4, 3, and any scalar multiple of those two vectors.